Hello and welcome to Mathematics with Simon. I'm Simon. Today we're going to look at the trigonometrical factor formulae, part of A-level mathematics. So here they are. Sin x plus sin y equals 2 sin x plus y over 2 cos x minus y over 2. There's also one for sin x minus sin y, which is similar. There's one for cos x plus cos y and one for cos x minus cos y. Note, cos x minus cos y is minus 2 sin x plus y over 2 sin x minus y over 2. We're going to look at how to prove these, because as mathematicians, we love proof. So we start with the compound angle formulae. Sin a plus b equals sin a cos b plus cos a sin b. We look at these in a previous video. I will put a link in the description. Sin a minus b, sin a plus b. Okay, what we're going to do is we're going to add sin a plus b and sin a minus b, because when we add them, what we notice is the second term is going to cancel. This cos a sin b term is going to drop off because it's here in plus and minus, and we're going to get 2 sin a cos b. So that's quite interesting. That sets us on the way. And the next thing we're going to do is we're going to define x to be a plus b and y to be a minus b, which looks like it's going to help us. Then when we add x and y, we get 2a, and when we subtract them from each other, we get 2b. Divide through both sides by 2. Divide both sides on both equations, and we get a equals x plus y over 2 and b equals x minus y over 2. Then we can substitute all of that into the above. So on the left we get sin x plus sin y, and on the right 2 sin a cos b becomes 2 sin x plus y over 2 cos x minus y over 2. So we've proved the first formula. Now we're going to prove the second one. Instead of adding sin a plus b and sin a minus b, I'm going to subtract them. We carry out the same substitution, pop it in, and we get sin x minus sin y equals 2 cos x plus y over 2 sin x minus y over 2. It will not surprise you to know that we take the compound angle formulae for cos to do the cos factor formulae. So cos a plus b is cos a cos b minus sin a sin b. Again, note the minus sign in the middle there, even though we've got a plus on the left. And on the next formula, we've got a minus here, we've got a plus there. Again, when we add them, the second terms cancel. We get 2 cos a cos b. We put in the same substitution, and we get cos x plus cos y equals 2 cos x plus y over 2 cos x minus y over 2. Similar approach for the formula with a minus sign in the middle. So when we subtract these two, the first terms cancel, cos a cos b, and you end up with minus sin a sin b minus sin a sin b, which is minus 2 sin x plus y over 2 x minus y over 2, because a is x plus y over 2 and b is x minus y over 2. Okay, now how do we use this? So how we use this is, let's say we were presented with this integral. Now, for those that know integration, this is helpful. For those that don't, we can assure you this is useful in a thing called integration, which you'll learn later on. So everyone should know integration, whether you're doing A-level maths or not. It's a wonderful invention. One of the most wonderful inventions, calculus. So if you start with cos 3u over 2 sine u over 2, this was quite hard to integrate. But what we sort of notice is that this integral looks a bit like the right-hand side here. And if we could choose x and y in such a way as to make this all work, maybe we could substitute the integral for the left-hand side, which might be more easy to integrate. So let's just say, for example, we want to get 3u over 2 here. We want to get u over 2 there. If we chose x to be 2u, and y to be u, then we'd have 3u here, and we just have u there. So it would all kind of work, right? So if x was 2u and y was u, then it would all work. We'd end up with this equation, if we change the sides, would be 2 cos 3u over 2 sine u over 2 equals sine 2u, which is x, minus sine u, which is y. And then we can, since these two things are equal, we can put this in the integration sign. It's going to be a half, because we wanted to integrate cos 3u over 2 sine u over 2, so we're going to divide both sides by 2 here. So it's a half sine 2u minus sine u du. This is quite an easy integral to do. So the integral of this is minus a half cos 2u, and then we've got another half here, so it's minus a quarter cos 2u. And then the integral of this minus sine u, so it's minus minus, so it's plus a half cos u. The integral of sine u is just minus cos, and then it cancels with this minus. Then plus c, because it's an indefinite integral, so you add the constant on. Here's another example. If we had to integrate cos 3u over 2 cos u over 2 du. Again, we notice this formula. Cos x plus cos y equals 2 cos x plus y over 2 cos x minus y over 2. You can probably guess the substitutions. You might want to take a minute to guess. You might want to pause the video. So basically, again, what we do is we do x is 2u and y is u. So here we get 3u over 2. Here we get u over 2. It looks like this. We've swapped the sides again. So 2 cos 3u over 2 cos u over 2 equals, we don't really need this bit in the middle. In fact, we don't need it so much, we're going to delete it. Look at that, we've deleted it. Equals cos 2u plus cos u. And also, the way I've animated the charts, look, it's going to keep cropping up. And as it keeps cropping up, we're going to keep on deleting it. Bit of real-time action there. So the thing is, so we divide both sides by 2. So what we get is the integral of cos 3u over 2 cos u over 2 du equals a half integral of cos 2u plus cos u. Now the integral of cos is sine, so this is a really easy integral to do. So all we're going to do is the integral of cos 2u is just a half sine 2u, and then we've got another half on the front, makes a quarter. And the integral of this cos u is just sine u, so it's a half sine u. So the answer is a quarter sine 2u plus a half sine u plus c. And it's quite miraculous that you can get that from this, isn't it? I mean, it's quite beautiful. Mathematics is truly beautiful. I hope you like this video. If you do, please hit the like key. You're very welcome to subscribe and the notification bell. I'd love to hear your ideas. And most of all, I hope you enjoy your mathematics.